Day three would be great. That would be when everything is fully automated. The tenants are managing their own stuff. The clusters are self-upgrading, self-healing. At that point, yeah, we can retire.
Hey team, Sid here, and this is DevOps Deployed, the show where we take a look at DevOps and cloud infrastructure in the wild. Each week, I interview industry experts about their experience building software systems and the teams behind them. Today, I'm joined by Bharat Sharma and Barak Stout, CTO and lead R&D engineer respectively at Raft. They build technology solutions for a variety of clients, utilizing a wide range of cloud-native technologies in the process. Bharat and Barak, welcome to the show.
Thanks for having us, Ted.
Yeah,
thank you. Excited.
Yeah, I'm excited as well. And so I like to start off the interviews with the same question for everyone, just to get a level setting of how you think about DevOps. And so we'll start with that general question. What does DevOps mean to you?
Do you want to take that first, Barak?
Sure, I can get us started. To me, it building software is about half the equation now. Actually, probably even less. Deploying it and getting it running in production and maintaining software in production, whether it be a CLI tool, an application that's running on the web, any kind of product that's out there and being used by end users, getting it from that developer to that setting takes a lot of steps these days, and it's becoming more and more complex. How we build software, how we deploy, how we maintain software, what kind of level of service that customers expect, right? I mean, we just had something happen last week where a big entity was down for, a couple hours? I don't even know how long. They didn't affect me, really. Yeah, and to people, that was mind-shattering. They lost themselves. There's millions of people that need that platform for their daily needs, and it was gone. So thinking about software from a more holistic perspective, and that it doesn't end with, I have my code, it's running, it fulfilled that use case or it passed that unit test. That's great, but what does it do at the end of it? How does it connect to everything, these bigger APIs and systems? It's a very deep word to me.
Yeah, there's a lot to unpack there for sure.
I would say, I think, as we all know, the intersection of dev and ops, I really look at DevOps folks to have developers as the users, first users, and then the core users are the users using the product. So as Barak mentioned, I mean, keeping those end users in mind is always good, but as a core job of a DevOps person, I look at as automation, so that we make those feedback loops shorter for the developers so that they can iterate faster, right? So, I mean, getting stuff up and running is one part of the job, but then the day-to operations of day-to-day activities of developers, how do we make their lives easier so that they can iterate faster and develop for the larger goal of the product? So I think those are two big things, and then collecting metrics, those fail-safe operations, I think those fall into the SRE, which we might look at it as a subdomain of DevOps, right? But those are overarching things. Yep.
Got it. And you use the term day two there. For anyone not familiar with that term, can you explain what that means?
Yeah. So day two operation is really where on the first day you might be provisioning stuff, right? You might be getting a Kubernetes cluster up and running, and that we categorize as day one. The day two is really when you start supporting customers or tenants, as we call it, that are using that Kubernetes cluster. So getting the operators running on it and getting those simple tasks that we might do day to day, every day, and automating those simple tasks, whether that's through operators, CRDs, or whatever API mechanism we might use using Kubernetes, but making that operation easier on an everyday basis is really day two operations in my eyes.
There's some that actually consider day zero the design.
Okay.
So day zero, typically you would design before you actually deploy. Day one is you gather all your tools, you built the house. Day two is sort of like, okay, now you're living in that house. What needs to be maintained?
And then do we ever make it to day three?
Day three would be great. That would be when everything is fully automated. The tenants are managing their own stuff. The clusters are self-upgrading, self-healing. At that point, yeah, we can retire. That's day three.
Day three is when we need an angle edge, right? To break into the servers to restart them, right?
Yeah, exactly. And so that gives us some framing about how you think about DevOps. Can you tell me more about what Raft is and what you all do there?
Sure, I can get that started. So Raft, we are a core niche digital consulting company. We primarily focus in the private sector. We've been early adopters into the cloud native ecosystem. So we've been building a platform in the open source for one of our primary customers, CFPB, Consumer Financial Protection Bureau. And some of the problems they came to us with, we went into the Kubernetes and cloud native ecosystem back in 2016. So based on that experience and lessons learned, we've been growing our presence into the federal ecosystem. We currently work with multiple agencies in the DoD, but our core premise is for in order to make the cloud native operations easier for developers to use. So we're always working towards that model of how do we make the developer's job easier. So that's really the core of what Raft is and what we do. We are very intentional about the folks we work with, even in the federal space. So bulk of the work that we do is bringing the open source private sector best practices into the government side.
Okay, and so will you come in for some fixed period of time and support a team on your a client team to build out these solutions, or what does that interaction look like, and how do the two organizations mesh?
Sure. So it's both. Predominantly, it is where we come in for the long term. We don't come in for a few months where we might fix a problem and go away. It's really a culture shift where we come in. So there are folks who bring us in. There's a concept of software factories within the DoD. So these software factories are quote unquote very strategically placed near Air Force bases, for example. And the notion is that that's how we are starting innovation within the Air Force. So we are involved in those software factories, and it's really a culture shift. DevOps and Kubernetes and all those tools are the our second part of the equation. The first part is let's get into that culture mindset of automating things, doing things in a scripted way, as opposed to throwing code over the wall and stuff. So most of our engagements are long, 3 to 5 year long engagements. There are certain places where a private entity might bring us in, or another partner might bring us in to give our core expertise for a 3 to 6 month period, and then we once they're able to stand on their own feet, then they can sort of get running after that.
Got it. And you mentioned this term software factories. Can you tell me more about what that means specifically? Is there an analogous term in industry or is it like a center of excellence? I've heard the term, but I'm not actually super familiar with what software factory actually means.
Sure. So I think analogous term to the private sector would be innovation lab. That's what I would categorize it as. So innovation lab, I think Netflix and AWS, they might call it something, but it's really an innovation lab within that large organization. So that's what Air Force has been doing. So I think right now Air Force has about, and I think Army is starting that as well. They have about 15 to 16 software factories all across US. And like I said, they're strategically placed close to the Air Force bases. And the part of the reason is that the work should be done in a remote way. The work should be done in a way where more folks from the private sector, such as ourselves, can come in and contribute to the DoD. But eventually, some of the solutions do need to be fielded in an air gap capacity, in a classified location, and what have you. So there should always be that capability to take something that was built in an innovation lab / software factory, but then eventually needs to go to the Air Force Base.
Are there any specific projects at RAF that you would want to highlight or talk us through sort of what a typical engagement looks like?
Yeah, maybe I can start with the CFPB one and let Barak talk about everything that falls under the Platform One umbrella, and Barak can talk about what Platform One is. So CFPB, like I said, Consumer Financial Protection Bureau. So we engaged with them so CFPB was stood up as part of the Dodd-Frank Act, and they took over the mandate called HMDA, Home Mortgage Disclosure Act. So as part of the Regulation C is a law that was written back in 1970s, but as part of the Dodd-Frank Act that got reenacted, and then CFPB started managing Regulation C. What that it means in simple terms is any financial institution across US that lends mortgages has to submit their data to the CFPB. And this data in the past used to be submitted, using faxes, emails, and what have you, and it was a very arcane process. There was no way for the government to, if you're getting faxes of mortgage data, you can't do analysis on it. So the goal was really, how can we make the process of submitting this data easier on the private industry, so on the financial institutions, while at the same time make it easier for the government to analyze this data as it's coming in real time. So we built, some of the problems that we were tasked with, we were going to collect about, 50 to 60 million records of data from about 10 to 15,000 big financial institutions. And all of the data was going to come in between 60 days, 1st of January to 1st of March. And since it ends up being as a compliance period for these agencies, for these financial institutions, bulk of them hit submit on the last 2 days. So we knew we would see normal growth and then hockey stick growth. So for that reason, we chose some of the things that we ended up choosing. We chose Kubernetes for our platform layer, so we could orchestrate our containers. And back in those days, we went with Mesosphere, which are now called D2IQ. That's a company. So we use Mesosphere to run our Kubernetes and manage our Kubernetes on top of AWS. For the underlying backend APIs, we chose the Scala and the Akka framework, so that we could really make best of not just functional programming, but also do parallel processing of the data as it's coming in. For the front end, we chose React.js, and for data streaming, we chose Kafka. And for the NoSQL, because we wanted faster writes, just because of that hockey stick growth, we chose Cassandra. So those bets that we made early on back in 2016 have paid off. We've been running this system in production for about 5 years now, 4 to 5 years, haven't seen a ton of issues. There's some modernization, slight adjustments we've made. We recently moved from D2I Mesosphere to EKS. So now we're leveraging EKS. As part of that, we had to migrate, which was a task. We had to migrate all of our Cassandra data on top of Kubernetes. So that was a humongous task for us to undertake, and we learned some lessons learned there. So our plan is also to start contributing some of those lessons learned back to the data on Kubernetes community, and some of our engineers will be doing that in the coming months. So yeah, that's a project and last thing, all of this work is done in the open source. So the entire platform for the CFPB is open on GitHub under CFPB, and I will just highlight, under CFPB as a government organization, they have not just this project, but they have a ton of projects that are all open source. So we're really seeing this customer embrace open source, and that really aligns with our core values of contributing back to the open source. So that's one that I would highlight.
Cool. As you select that tech stack and start to build something like that out for the Consumer Financial Protection Bureau, how are they giving you a set of requirements and you are designing the system from those? What does that process look like as you choose sort of that set of tools and then build out this system?
So I think it's really we work on the problems, the business problem first, really try to understand the business problem, and then we pick the tool. So we engage in what we call a discovery and framing process, where we talk to the end users of these financial institutions, and they tell us what are some of the problems that they're seeing. Take that back and then do a very small POC where we might look at the large problem, break it down into a smaller chunk, and validate that whether these technologies as combined would be able to solve this problem or not. And that's sort of what we did. We started with an MVP phase, rolled it out internally, then rolled it out external to the agency, and then really worked collaboratively from that point on and in an iterative fashion.
I'm sure there's a bunch of lessons learned as well from the consumer online sales, with Black Friday having a similar crunch time relative to that submission deadline, right? Of like, most of your systems will have a peak of many times their normal load in a single or few days. So I'm sure there's some lessons learned there as well that you can bring in.
Yeah, Brock, do you want to talk about load testing and stuff? And I mean, that all of that rolls into Platform One and DoD work as well, right?
Yeah, I mean, it's very interesting when you have to design for the worst case scenario, and when you design for that with that in mind, but you don't want to always be in that mode. You don't want to always be running extra EC2 instances. You don't want to be running the bill too high. Yes, it's government, and they have the resources to run things, but that doesn't mean you always have access to it. Everything needs to be computed out. So part of making sure that the platform is ready for that load is in the months prior to our production day, which is January 1st. We will run load test. So there's a tool called Locust. It's a Python script. It's really easy to work with. It has a simple API that we have programmed our users' behaviors with the platform, and we would run it at ridiculous scales, like much more ridiculous than the tens of thousands of banks that we have. So I'll run it with like 100,000 banks. I'll run it with 1 million rows of files that take a while, and we'll clog up our system to see where the breaking points are and whether it's Cassandra failing or is our platform failing because there's not enough pods, is the auto scaling not working properly, and really testing out all these things and finding out like there are weird dependencies because it's built upon many layers. One of the times we broke Keycloak, which we use for authentication, and it wasn't even our platform at that point. It's digging into Keycloak and the JVM settings for Keycloak and why did that break, or something like Ambassador, which handles some of the logic of traffic. There's all kinds of different pieces that can really benefit from load testing, and because Stacks, I guess this is what leads to Platform One. So Platform One is one of the software factories of the Air Force. And each one of the software factories not only is strategically near a base, they sort of have a mission in mind that they're really radically focused on. They're trying to solve this one thing really well for the DoD. Platform One chose to take on the role of DevSecOps and to really embrace that idea. So they came up with the Iron Bank, which is publicly available, and it's a registry of hardened containers. So if you need a container, so containers have a lot of security vulnerabilities. It's kind of like Docker Hub, but a secure Docker Hub that anybody can use. And it benefits the entire DoD. We've even heard of people outside of the DoD using images from there just because they're cleaner, they're safer to run, and they don't have any vulnerabilities. Everything is up to date. So they maintain that registry as part of what they do. The other side, one of the other things that they do is they have this product called Big Bang, which allows you to deploy essentially a stack for a software factory. So just like we have for CFPB, for every application right now that is deployed needs some basic common stack that we all run on Kubernetes. We run Elastic, we run Grafana, we want to be able to monitor pods, and we want to run things like Falco in the background. There's a certain stack that should be common. And what Platform One did with Big Bang is they made it so that Big Bang is infrastructure as code, and it deploys your cluster and configures your cluster that is already compliant. And there's some inherent government sign-offs from it of saying, hey, I can run this on Big Bang, meaning it is secure already inherently. All the images to run Big Bang come from Iron Bank. It inherently plugs a lot of holes. So that's one of their products. So combined with the two, they have their third product called Party Bus, which is where applications can get deployed. And yes, the naming is hilarious. Their logo is a little baby Yoda in the forest. It's adorable. I suggest you go look it up. really cool people, develop really cool things. So they took Iron Bank and Big Bang and deployed Party Bus. And that means that if I have an application that I want deployed somewhere that's DoD approved and run it in production, I can go to Party Bus and they'll just run my application. They'll give me GitLab access. They'll give me whatever I need to put my code in, and they'll run that pipeline. They'll take care of that developer to production side of things. So what's happening now is some of the other software factories are starting to use that product. That product got to a maturity level that they don't want. Their Party Bus is sort of a limited area, and they're trying to really get software factories to stand on their own 2 feet, take Big Bang, take images from Iron Bank, take the lessons learned, and stand up your own factory. And because that's really where we're going. We need people to be closer to the clusters. We need to modulate things. We can't have all the DoD apps running on a single multi-tenant node. Like that's not good practice. That's not what Kubernetes was built for. It was built to have mini clusters all federated. So what we're working on now is we're working on a few efforts to deploy software factories for some agencies. We're working on modernizing some of the software factories that chose older technologies that are migrating onto Kubernetes at the moment. Not Big Bang, but other flavors like RKE2. And then we are also working to enhance Big Bang in a way of adding some capabilities that Platform One did not have in mind or will have in mind maybe 2 years from now, like hardware in the loop. And hardware in the loop gets me really excited because I think that's really the next thing that's happening right now. So we have all these sensors and all this hardware all over the place, and we really want to program it, but we can't program it yet as natively as we can program computers.
Got it.
And deploying code to it becomes more tricky. Like there's a whole bunch of problems with it.
Yeah. I want to, before we jump into hardware in the loop, let's touch on a few things that you mentioned there. So you talked about Iron Bank as this sort of secure version of Docker Hub with these images that have been assessed and approved for usage. Big Bang then was this infrastructure as code, Kubernetes based. Is it like a set of templates, or what's the underlying tooling there? Is it Terraform or something similar?
It's Flux. It uses Flux v2.
Okay.
So Flux is a infrastructure as code. What it does basically is when you install it on the Kubernetes cluster, you configure a Git repository to pull from. And then the Flux operator that's running on the Kubernetes cluster will listen to that repo and it will pull any changes. So as soon as you merge a PR, you say you merge a PR to up the CPU, it will get merged and applied to the cluster, if the cluster can pull and read from wherever it needs to read from.
Got it. Yeah, Flux is a tool from Weaveworks using these GitOps principles that you just described. And I think one really nice thing about it, right, is that you no longer need to give credentials for your cluster to your CI/CD system, and instead you can keep that boundary a lot stronger and put those credentials in the cluster and pull the new images and configuration from there. And then if we move on to Party Bus, this managed version of Big Bang, it's almost like a platform as a service offering within the DoD. Is that right? And what level is the abstraction there? Is it like they are giving you this cluster and then you work from there, or is it more like a Heroku where they're adding CI/CD automatically and that sort of thing?
I think it's closer to Heroku with less visibility. Like you have very little visibility. Your interactions is committing your code to your repo, and from them there's a Helm chart that gets picked up by their own CI/CD, which you can see some of the error logs and stuff in the browser in GitLab, or you can see some of the error logs or some of the logs
of the
running pod. Well, yeah, there's never errors in Kubernetes. No, all my code runs on the first time, Sid.
That's right.
Yeah, so it's very interesting from that perspective. You're very far away from the actual deployment, but that's where their support comes in, and a lot of stuff does end up with I have to get access to the Kubernetes layer, but they don't give access because they're trying to follow the GitOps model where you don't give access to clusters, which is hard to do right. And that's where it needs to mature to, and that's where we are maturing to, I think, in general as an industry, both in open source and in the government space. We're getting to the point where Kubernetes just became an abstraction by itself.
I work with a lot of startups, and I'd say most of them have not reached the full pull-based GitOps deployment model. Like they get to a CI/CD system that's the final step of the Circle CI job, or the GitHub action is a push-based deployment, and that works pretty well. And so making that final jump can definitely be a big leap and change in mindset for sure. Did you want to touch on any of the hardware in the loop work before we move on?
Yeah, so hardware in the loop is very interesting to me. I started exploring it early on when tinkering with Raspberry Pis and trying to get code deployed to it, and always get annoyed that I have to do so much. So it's been an exploratory and sort of an R&D phase with the military as well, because they need it, and they know that they need better ways to program some stuff on the fly. But they need it for some basic stuff like getting logs off of like devices that are running in an aircraft. All the technology that we think about and we take for granted, oh, I can touch my phone and pay for things, I have Wi-Fi around the house, those things kind of end at the boundary of the base. There isn't Wi-Fi everywhere. Gigabyte connections are wonderful when you have them in commercial areas, but we're talking about low bandwidth areas. Some places can't support video, chat. So all these extreme cases where hardware exists for the military and that they want to code it, it becomes a disconnect. It's almost like its own sub-problem, and every device has its own set of APIs. It's a physical hardware that you need to figure out how to connect to. And in some cases it's doable, in some cases it's trickier. So I think it's a problem that has many faces and needs to be solved. But like Bharat said in the beginning, it's a problem that's 2 years away from them. They're trying to get the web development experience there, and to get the basic application development experience there. They're not yet at the point where Kubernetes intersects with hardware, where I think consumer industry is getting to. The IoT devices, you can run Kubernetes on very small footprints. You can have it as part of a node of a cluster. It doesn't even need to run Kubernetes by itself. You can just run a small kubelet as long as it can run some flavor of Docker. Mm-hmm. And shifting to that is a huge mindset shift. And I like it because it's challenging, but it's also a lot of poking people that have been sitting idle with the status quo of, oh, I can deploy code to a CD, walk it across the hole, put it in another machine that's going to run the test. Then we're going to take the CD out of there and eventually get it to the warfighter, which needed to be updated 6 months ago. And it's a shorter loop, but it's a lot of changing things that they're used to now.
I've seen some of the work that you all have done on open source, and I think you've written about it on your blog, using Raspberry Pis to demonstrate some of this hardware in the loop concepts. Is the strategy there to sort of establish a set of best practices that as your clients become ready for this type of thing, you'll be well positioned to help them out on that front?
Yeah, it's definitely a learning exercise, and I'm curious about all things. Like this week, I learned Go. I just keep going and keep exploring things, because I think that's how we grow, and that's how we learn and become better, by doing things that are different. I think for us, we've been doing a lot of the work to already include it as part of the stack of Big Bang. So when new software factories come up, if they are interested in hardware, it's already ingrained in there, and they're not starting at square zero really at the design phase. So it is closer to a day two. It is closer to operational, and then it's just tweaking it for that operational use case, because the ideas are the same, the theories are the same, how we interact with the hardware is the same. It needs to also translate and move maybe across the wall to some place that doesn't have internet connection always, but needs to run this platform and give these capabilities. And the only way we get there is starting now. Like, we need to start on a lot of things now.
Yeah, and I think one of the other problems we're also facing with hardware in the loop is what the end hardware is, right? So right now, what we've posted on our blogs is focused on Raspberry Pis, but some of the clients we work with have specific hardware devices that are some are classified, some we can mock out in our lab, but those our pipeline at the end stage changes based on that specific hardware device, right? x86, ARM, those are all. But what we're trying to do is getting the foundation right so that all those, in the end, the last stage is really a configuration change based on the specific hardware device.
Yeah, that makes a lot of sense. And so we've covered a variety of different projects and initiatives that Raft is focused on. Can you talk me through and sort of compare and contrast what the difference is between working on these contract-based projects? And you mentioned that they're fairly long, so there is a deep integration between Raft and your client teams, but maybe how that differs from DevOps as it manifests within a company. So like most of the other interviews that I've done so far in the series have been with startup founders who are building out the systems for their company, and it's sort of one continuous thread. How do you think about it, and what's your mindset as you have these multiple different clients where you're helping to apply DevOps best practices across all of them?
I think the way I would describe it is it's the same thing as you describe in the private sector, but doing it in a larger scale, right? So say you're doing it for, you're doing set of best practices for Netflix, and some engineers might be doing set of best practices for, say, AWS, but what is the common thread between those? And if there was just one team doing both of them? So what we try to do in most of our efforts is find the common thread. So we talked about CFPB and Platform One. There's a ton of common threads there. We're doing some of the work with Data Fabric, and maybe we can talk about Data Fabric, but data related on top of Kubernetes, that has a lot of common threads associated with it. So what we're really trying to do internal to us as a company is build a set of tools that we can reuse across different clients, right? So if we have those set of built tools, then it makes our job easier, and that in turn benefits the government as well, because now some things that we could do in, say, 8 months, we can do them in 4 months and cut the time in half. So that's the way I really look at it. I think from my perspective, our focus is to take take the best practices from the private sector and bring them into the government so that we really change have that mind shift of not every agency across the board is reinventing the wheel. So, if we're in 6 software factories today, there's definitely common threads across the board for them. And although they have mission goals that are specific to them at a technical level, there are a lot of common threads that we see between them.
Is there anything you do in particular in terms of structuring the organization of teams at Raft to help share those best practices? Do people move from one client project to the next, or what does that look like within Raft?
Yeah, so we structure our team sort of in 3 ways. One is, you're dedicated to one customer, one software factory, where you, rather than going wide, you go deep, right? So you really try to understand what that software factory's pain points are, and then you become an expert in those. The second is we have a core team of infrastructure folks, so DevSecOps, whatever we're going to call it. Those are folks who work across different projects. So they're the folks, that's a team. We have a team of 5 to 6 folks, and that's a team that sees the common threads across different projects and builds those internal tools for us that we can apply across projects. Then the third team we're standing up is the team, as I like to call it. So what, you have a Kubernetes cluster, right? What do you do with a Kubernetes cluster? So that's a team that our focus is really streaming data. So whether it's streaming data, whether it's collecting metrics from your Kubernetes clusters, basically doing everything with data, but doing it on top of a Kubernetes layer. But for them, it shouldn't matter the layer is Kubernetes. It could be bare bones EC2 instances. So that's ton of our focus in the coming future. So those are 3 ways how we are structuring our teams internally.
Yeah, that makes a lot of sense. And as you approach clients and figure out how to position Raft, can you talk at all about the business development side of things and what the contracting cycle looks like, how you position the company and teams to be well suited for these projects?
Sure. So I think from day one, we've been very intentional about the folks within the government that we work with. So we don't necessarily go after any quote unquote contract. We're very mindful of the people we want to work with in the government. And the people we want to work with in the government they also want innovation within the government. So that's a common layer where we both align. And if we don't align there, we just can't work with them. So that's been our goal from day one, and that's how we got connected with CFPB. And then when Air Force was starting their cloud native journey, we got connected with them. And so that's really our way of we want to be niche and doing one thing and do that one thing really, really well, as opposed to do everything across the board. As far as the business development cycle goes, I mean, the cycles in the government are long. So any customer that we're working with today, we probably started engaging with them about a year ago. Any customer we're engaging with today, we might start working with them a year from now. But our pitch or elevator pitch is really to the government that you are seeking the same things that the industry has done and other agencies have done, and we've been part of both. And if you engage with us, we can spin up those things in a much faster way and show you a culture shift around those technologies as well, because it's not just about bringing the right tools, but knowing which tools to bring in to solve which business problem. So that's as far as the business development cycle goes. I mean, I can go in more depth into that, but in the government, there's a concept of vehicles, quote unquote, what's called vehicles. So if you're part of a vehicle, you are core set of companies that the government works with, so that it's easier for the government to work with a pre-vetted set of companies as opposed to working with, I don't know, thousands of companies. So we are part of those such vehicles where we are focused on sort of the DevSecOps side of things, and that's really bulk of the BD work that we do there.
Yeah, and that's the second or third time we've heard the term DevSecOps in this interview. Do you want to explain at all the difference between DevOps and DevSecOps, or any nuances there that you want to call out? And Sec standing for security within the combination of words, obviously.
Sure. The way I would define it is security isn't an afterthought. It becomes a day zero thing. Like, you're thinking about security on day one. So as we're talking about spinning up software factories and the infrastructure, we are keeping security in mind from day one. So in the DevOps world, just taking an example, in the DevOps world, you might look at CI/CD pipeline as I want my code deployed from Git push to whatever I say, staging, dev, or prod. And that's what DevOps would be. DevSecOps would be, as part of my CI/CD pipeline, my code only deploys when it doesn't have any high vulnerabilities. So as part of the CI/CD pipeline, you would do the the static and dynamic code analysis. You would do the vulnerability assessments on top of your containers, and there's various tools in the industry for that. And then you put in the guards that, hey, you can't deploy unless there are only, say, low vulnerabilities. On the Kubernetes side of things, I think being able to deploy from a pre-vetted Docker registry, right? So whatever registry of your choosing, you should be able to guard your Kubernetes cluster so that you can only deploy containers coming from that registry. So Barak talked about Iron Bank. The clusters or Kubernetes clusters that Platform One manages, they're secured such that only containers from Iron Bank can come in there, right?
And are you doing that with something like OPA, Open Policy Agent, or how are you enforcing that type of thing?
Yeah, it's OPA. OPA is being used right now for doing that. In the past, I really like a tool from Fairwinds as well. I think called Polaris, or Goldilocks would do that. Sorry, not Polaris. They have a tool called Polaris as well, but Goldilocks would also do policy management at that level. But OPA is what we're using, and we're using OPA for some of our data work as well. So that was just the best choice there. So that's how I would define DevSecOps.
Yeah. No, I mean, I think in an ideal world, security is not an afterthought within DevOps, but I think people use the term DevSecOps when they explicitly want to call it out as a priority within the DevOps function. That's sort of how I see it and how I see it being used across the industry.
And there's, I mean, on the CI/CD side as well, right? Just to throw sort of another thing for the DevSecOps side of things, there is a concept of what's called ATO in the federal side. ATO basically means authority to operate. So unless you have authority to operate, you can't deploy anything to production. So there's always been a long gap between the code you deploy and when somebody receives ATOs to be able to take that to production. So the bulk of the work that's been going on in the DevSecOps, at least on the federal side, is how do we shorten that gap, right? How do we shorten that gap so that developer can get ATO as part of their pipeline? And that's where the concept of CATO comes in, which is continuous ATO. So the way that's being done right now at a very high level is the CI/CD pipeline itself is ATO'd. So soon as you can say that, okay, my code went through the pipeline with all green tick marks, then that automatically means that I have ATO, and at that time I can deploy to production. So those concepts are very a lot of focus of the DevSecOps arena of the field.
Yeah, and that's interesting, sort of the formal sign off on the process, such that if the process succeeds, and as you mentioned, all the tests are green and the checks are passed, then you can proceed. And I think that formality is unique to some of the work that you all do.
Yeah, I think what he's not saying is if you fail any of those pipeline steps, you don't get to deploy, and you don't get to land on go and collect 200, kind of a thing. Then you have a problem, and sometimes it's on you. Sometimes it's just a random thing, like a Python package got updated, an NPM package was found vulnerability. So a lot of times it's one of those, you commit your code, you open the PR, you let the pipeline run, and hopefully it gets to production as soon as you can, but it might not because the pipeline failed. And the pipeline is really what's approved or disapproved. It's not really the application. It's the application too is part of it. So in the initial ATO, they will sign off on the pipeline and the application, and then everything else goes through the pipeline. It's a dual-headed spear, if you will.
Yeah, I mean, I think that people and companies are always trying to balance the velocity at which they can develop and deploy their applications with the necessary security and promises that they're not breaking things. And so I think there's a constant tension there within the DevOps world of how to continue to increase velocity while maintaining the same level of guarantees and likelihood that you're not causing issues.
Yeah, and security is everywhere. Like, we're talking about DoD because we are in that arena, but I can't think of a single industry right now that's not susceptible to some level of attacks on a constant basis. In the medical field, you have HIPAA laws that you have to regulate with, and patient data and everything. Yes, COVID made it a little bit fudgy, but it's still a lot of personal information. You can't be running containers in that arena that are not secure. You have the same in financial industry. You don't want to run anything that has vulnerabilities. It's across the board, and anybody that does anything useful right now in the software world. And none of us develop software in a bubble that is not affected by the need for security. So why not include it in the process? That's the way I think about it, at least.
Yeah, totally agree. So we're coming up on time. I'm going to ask one more question. Are there any lessons learned that you would like to share with others who are building out their DevOps systems at their company or organization? Lessons learned from your time at Raft or prior?
There's so much to think of there, right? So I can start, and maybe Brock, you can follow from your perspective. So I think our lessons learned are really coming from iterating on providing that Heroku-like experience to the developers. I think not just from Raft or DoD. I think as an industry, we failed there. I think Heroku and sort of Pivotal Cloud Foundry, those folks, I think they had that down. The developer ease of throwing your build pack over the wall, and I don't need to know anything about it. I just write this buildpack.yaml file and I'm done. But now on Kubernetes, a developer has to think about ingress, egress, PVCs, and all these things. And I think if we can do that better for the developers, then we're serving our customers well. So part of that we're solving every day. We iterate faster on that, but I think just removing the concept of quote unquote Kubernetes in general, so that developers don't have to focus on the nitty gritty details of Kubernetes, but rather focus on whatever they're building and don't have to worry about the infrastructure details and writing multiple YAML files. I think that would be a lesson learned from my perspective. And we're doing some of that as part of CLIs and just abstracting that layer. But that's something I would say.
Yeah, I think finding that right level of abstraction where you're guiding the developer and keeping them on Rails to achieve what they want to, and exposing the right level of access to the underlying protocols to achieve their necessary needs is a key aspect of DevOps for sure. Anything you want to share, Barak?
Yeah, I guess for me, I think it's all about what can you build with more than yourself. So it's really about reaching out and collaborating and sharing what you've learned, and not necessarily keeping things siloed up. Has been something that I try to perfect every day and get better and better at. It's how we can build stuff that are way cooler than what we can do. Sure, you can lock me in my basement, give me a month, I'll build you something cool. But if we all build a little bit and show each other what we're building and how we're laying these bricks, we can build a nicer castle all together. I mean, there's limited time a day. I can't clone myself. Trust me, we've tried. We can't invent more hours in the day. So the best we can do is help each other grow towards that perfection in the end, which hopefully we will never achieve.
Great. Well, thank you so much for coming on the show. Is there if there's people out there listening, what do you want them to do? Should they check out the Raft website, the career section? Where should we send them?
Yeah, there's a Raft website, which is going to be revamped soon, but there's a career section, there's a job board. We are always looking for problem solvers. If you don't know all the tools, we don't know all the tools either, but if you're willing to learn and, see how to solve problems and what tools to pick to solve those problems, we're happy to have you and show you how deep the rabbit hole goes, and would love to work with you so that we're not building in our own silo like Barak mentioned.
Great. Yeah, I'll leave a link in the description for that. And if people have questions that they'd like to ask, leave them in the comments section and we'll try to get them addressed. All right. Thanks so much.
Absolutely.
Thank you,
Thanks
Sid.
for having us.
Take care.
Thank you. Bye-bye.
Bye.
Bye.